Hi, everyone. For this session today, we're going to be talking about AI-powered testing in Visual Studio. First, a little bit about myself. My name is McKenna Barlow, and I'm a PM on the .NET Tools team here at Microsoft. My team focuses on testing, so basically everything from the Test Explorer to some of our new AI-powered tooling that helps you write and run and just understand your tests faster. Over the last year or so, we've been really hard at work reimagining what testing looks like in sort of an AI assisted world. And at the core of this, we're thinking about how to go beyond what your IDE can do, just running your tests. So imagining if your IDE could help you write your tests, help you understand what might be missing, and even evaluate the quality of your AI systems. So in this session, we're going to explore how AI is changing the way that we test in Visual Studio step by step. And we're going to get a really good look at what's in Visual Studio 2026 in terms of testing. And some of these will be brand new features for VS 2026. And some of these will be things that were available in previous versions of Visual Studio that we've just made a lot better. So I'll start with a look at code coverage and how it helps you understand your test quality at a glance. And then we're going to go through some of those modern testing tools like the Test Explorer, live unit testing, Code Lens, and hopefully fix some bugs using Copilot from there too. After that, I'm going to demo our newest capability, GitHub Copilot testing for .NET, which can automatically generate high quality unit tests for your whole solution at once. Then we're going to take a look at MEAI evals, or the Microsoft.extension.ai evaluation libraries, and how they can help you test your AI generated output. So whether you're maintaining some legacy code or you want to improve your test suite, or really you're just curious about where AI fits into the modern developer workflow, this session is for you. So let's go ahead and dive in. Before we jump into I wanted to start with something that every developer and tester knows, code coverage. So we're going to start with the basics here so that we can kind of build off of it later on. Now, code coverage tells us which lines of code are executed by our tests, and then by extension, which parts of our code base are uncovered or untested. And it's available to everybody in Visual Studio 2026. And when combined with AI, it can be really powerful because coverage doesn't just measure how much you've tested, but it can also sort of guide where Copilot might be able to help you or generate tests in places where you do have that lower coverage. Now, this matters because uncovered code is really risky, right? Bugs can pop up unexpectedly, and things that you didn't really intend to happen as you were writing your code can happen. And so we want to use code coverage in Visual Studio to give you a good sense of where you might want to add tests, where you might be overconfident, and like what's safe to refactor and what might not also not be safe to refactor. But before we jump into Visual Studio, the last thing I do want to mention is code coverage reporting in your CI/CD pipelines. In terms of code coverage reporting, we do have some new improvements in the reporting experience that I'll show you here today. But you really want to get to a level of like 70, 80% code coverage as the industry standard. And if you're going to measure your code coverage in things like your build pipeline and an automation or like GitHub Actions and things like that, they're going to require about the same threshold there. So by using some of these tools, you can hopefully kind of find those issues earlier and get your code coverage up to a higher percentage so you know that you're minimizing your risk here. So let's jump into Visual Studio and see what code coverage looks like. So here in Visual Studio, we have our classic eShop app. We often use this for demos. It's basically like our microservices, cloud-ready e-commerce site, and it already came with a bunch of tests. So I have the Test Explorer window open, and I can also, if I don't have it open it from the test menu, but it looks like I have 105 unit tests for this solution. Now I just built my solution and ran my tests, so I can see that most of them are passing. We do have this one failure, but let's ignore that for a moment. We'll address it later. What I want to look at here is the code coverage for these tests. So to check my code coverage for these tests, I'm going to open up the test menu and select Analyze Code Coverage for all tests. Visual Studio will then go ahead and run the tests and generate a coverage report. But I've already done this, so let's go ahead and pull that up. Now, in this coverage report, we can see the number of covered lines, partially covered lines, lines that aren't covered, as well as total coverage percentages. So I can get just a pretty good view of what's going on here overall. Let's take a look at the toolbar to see what we can do with this. So if I've already run the tool before and I have some results that I want to import, I can do that. I can export my results to generate a report, which I'll show you here in a second. I can merge some results if I have two different reports and I want to bring them together. And then I have some code coverage coloring. Here we have line coloring and margin glyph coloring. I'll also show you this as well. I can also remove things that I don't want from this view, or I can go and configure my code coverage views. You'll notice here that in this current view, what we see in this results window isn't really grouped in the same way as you're used to and like how they look in folders and on disk. And this is because the results are by DLL here in namespace, because the information is collected at the assembly level and it reflects how the code is compiled rather than how it looks on disk. But if I wanted to get that different view here and see things more like how they look on disk, we can also do that and get that source view. And maybe things are looking a bit more familiar. Or we can go back to that project view. If I want to add more columns here, I can also right click on the columns and add or remove some of these metrics here. And I wanted to mention that we have some really great pre-built filters. So if I wanted to look at certain conditions here, like for example, where I have greater than say 70% coverage, I can go in and add these things. So I don't actually have to build these expressions myself, which is really nice. And these are kind of like the most popular ones and the ones that we think will be the most helpful to you. So let's go turn on the coloring here and see what that looks like. Now, if I go into my code, I have some line coloring in the editor and also glyph coloring here on the left in the margin. So this bright blue is showing me code that is covered and red is showing me some uncovered code. So I can kind of just scroll through this, and this is my basket service. This is really helpful because I can just go through my code and see at a glance what is and is not being covered. Unfortunately, I am noticing a lot of red here. So I know this is an opportunity for me to go and improve my test coverage for this project. Now I want to show you what some of these reports look like. So I'm going to go and hit export. And this window comes up where I can now save my coverage report. It's going to save it as an XML file, but I've already gone ahead and done this. And once we have the XML file, we can use the report generator dotnet global tool to get us an easily readable HTML report. So before I do that, I want to jump back in my deck and show you the commands that you use to install that and run that tool. So I did already go and install the .NET Global Report Generator tool with this first command. And then once I have the tool installed, I'll go and run the second command in PowerShell to generate the report in HTML format. So as I mentioned, I already did do this, so let's just go ahead and take a look at it. So here's my report. Again, I use the report generator .NET Global tool for this. I can see that I have overall 46% coverage for my whole solution. It could be a lot worse, could be a lot better. Now this view is really nice to go at a high level and just sort of see what's going on with my coverage, but we can also dig into some of the details here. As I scroll, we can get a little more of a granular view of the line coverage for these individual classes. So if I scroll through this list, I can get a sense of like what areas of my code might need a little bit more testing love. It's kind of a mixed bag with this app. I'm seeing green in some places, a lot of red in other places, like the parts where I'm doing identity in this app, for example. So this is a really good opportunity to go and add some more code coverage. I can also dig deeper into these by like clicking into them. So for example, let's find a good one here. I could go in here and click in and see now for this class, I can see each of the methods, how many blocks are covered and uncovered. And if I scroll down, I can get sort of like that similar view to what we saw in Visual Studio with the line coloring turned on. And then here in the report, there are like some other fine-grained things that I can do. Like I can change the grouping of how we're seeing these guys down here. I can also select different types and metrics of things I want to see. So there are really a lot of different types of reporting that are just right out of the box for you here, which is pretty awesome. Now I'm going to go back into my project in Visual Studio so that we can check out that failing test. So first, before we actually dig into this, I'm going to turn on live unit testing so I can show you what that's all about. So I'm going to view other windows and live unit testing window. And I already have this turned on. And what this is doing is it basically goes and runs my unit tests in the background and presents the results to me in real time. So this is really helpful because I won't have to go back and forth between the test explorer and my code and like rerun all of my tests every time I'm making a change. And I'll mention that I have created what we call a playlist here, which is like the same as music, where you're basically just adding what you want to run. And I've just added those basket unit tests because I know the failing test is there and I want to keep an eye on them. So now that I have live unit testing running, I'm going to try to use Copilot to see if I can understand what's going on with this failing test. So let's look in the test explorer in the output and see what information we can find. So it looks like the issue is with this get basket method, but I don't really know what's going on. So I'm going to ask Copilot to explain this failure. Okay, so now we're seeing in this method, a valid user ID is present and the repository returns a non-null basket. The code incorrectly returns a new empty customer basket response. Interesting. So this to me looks like maybe something is null when it's not supposed to be. So let's go look in our code and see if we can figure out what's going on. Let me turn off this line coloring because that's a little hard to see what's going on. So we're in this get basket method, and I think I can immediately see where the issue is here. We have if data is null, return. I don't think we want to be returning when the data is null. I think I messed up here and my logic is reversed. This is going to be when data is not null. But before I actually go and fix this code, I do want to show code lens here. One of the things that you can see with code lens is the tests for a given method. So if I click in on these tests, I can see sort of like this heads up display here where I can see how my tests are doing for that particular method. And this get basket is failing. So I could click on this specific test and like run or debug right from my test classes. So I'm not having to go back to the test explorer to do this. But let's go and fix this bug. As I do this, keep your eye on the live unit testing window and we can see it get to work right away. So now when I fix that bug, we can see live unit testing is going to work and it's going to rerun those tests and tells me that those tests are passing as soon as I make that change. So this is great. All my tests are passing, but I do know that I have low coverage. So there's definitely an opportunity there. So let's take it a step further and boost this coverage. And this is where things get really exciting. So I'm going to jump back into my deck. So I'd like to introduce the new GitHub Copilot testing for .NET capability, which is a brand new hot off the presses feature that is available today in Visual Studio Insiders with no extra installs or setup or anything. GitHub Copilot testing can automatically go ahead and generate unit tests to cover more scenarios and just improve your code coverage. And this is whether you're starting with no tests or you already have some coverage going on. You can think of it as your AI-powered testing assistant that will analyze your existing code, suggest some meaningful test cases, and it helps you close your coverage gaps really quickly and with confidence. This is also a more comprehensive experience compared to just writing a prompt. Here you can actually automate the generation of your tests for a given file or a project, or even your whole solution at once. So let's see what this can do for my eShop application's code coverage. Earlier today, I asked GitHub Copilot to generate more tests for this Basket API project so that I could take you through this experience. Timing for you will depend on the scope of like what you ask Copilot to generate on, whether that's like a file, a project, etc., all the way up to a full solution. So I wanted to be able to fit this in this demo and still have time to show you some cool stuff with evals after this. So I do have a recording here where I fast forwarded through the bits where all the tests are generating and running, basically. So let's take a look. I'm just going to focus on the Basket API here. And if we go ahead and look at that code coverage, we can see that that coverage is like 3 or 4%, which is really not great. So let's put GitHub Copilot testing to .NET to work here and see if we can improve the coverage. So I'm going to start the flow by opening a thread in Copilot chat and choosing @test, and then choosing the Basket API project. And you can also pick your favorite model to work with here, which I love. Copilot is then going to start by analyzing the project to just like understand what's testable and what's going on there, and then create a plan to generate tests. We can see this process start to kick off as the unit tests begin to be generated. GitHub Copilot testing will look for existing test projects where it would make sense to put these generated tests, but it can also create them if you don't already have any set up. So it's going to start with generating tests for things like controllers and key services, and then work its way through the solution in a way that makes sense. And then once the tests are generated, it'll go ahead and validate them to make sure that they're just like running and passing and everything looks good. I do want to mention here that the tests are determined or they're generated deterministically. So they're grounded in C sharp compiler and language semantics. So your assertions and your edge cases are going to be predictable. They're going to be type safe and tailored to your specific code. So then we can see what's going on in the GitHub Copilot chat right now. We can see after planning was completed, uh, Copilot's gone ahead and created all these different test files. And then once the test files are created, it's going to go and run the generated tests. And if any are failing, it's going to go ahead and fix those failing tests. And then when it's finished, it'll measure the final code coverage for our project so we can see what the results are. Then when it's totally finished, we'll get this nice summary in Copilot chat that shows us what was accomplished. And we can see if we scroll up a little bit that it generated 59 new unit tests. And look at that impact on the code coverage. We were at like 3 or 4% before, if you remember, and now we're at around 46%. So like a 42 or so percent increase in coverage. So with just a few clicks, GitHub Copilot testing for .NET has helped us generate really meaningful unit tests, improving our coverage without the manual grind that it would typically require. And this is a really huge step towards making testing as effortless as writing code can be. But here's the important thing to remember. This feature is brand new and it's currently exclusive to Visual Studio Insiders. So if you're not on Insiders yet, this is the perfect reason to join. Go ahead and try the tool out, push it to its limits, and please let us know what you think. You probably already know this, but your feedback really is critical to us. It's how we make these things even better for you and the entire developer community. So go ahead and give it a spin, share your thoughts with us, and help shape the future of testing in Visual Studio. Next, I want to pivot a little bit and talk about some AI evaluators. So these days, everyone's using AI and LLMs in their development, and it's certainly changing how we build software, but it also introduces some new challenges. Typically, your first line of defense for like validating the output of your code would be your unit tests, which work as a binary pass-fail for a given block of code. But what happens when you start talking about how to test the output of LLMs? LLMs are non-deterministic, meaning each time with the same prompt, we might get different results. So how are we going to determine if this output should be a pass or a fail? It's not so black and white. We have this key question that emerges, which is how do we know that the AI did a good job? So this is where evals come in. Evals or evaluators are like basically unit tests for AI outputs, and they let us measure whether a response meets criteria like correctness, safety, relevance, alignment with intent, or really any custom metric that's relevant to your domain. So we have Microsoft's MEAI evaluation libraries, which stands for Microsoft.extensions.ai.evaluation. It's quite the mouthful. These libraries will let you bring your evaluations into your .NET workflow seamlessly alongside all of your existing testing infrastructure. So you can use your same favorite testing framework, so whether that's MS Test, XUnit, NUnit, and all the same workflows that you use for your other testing, like the Test Explorer, .NET Test, or your CI/CD pipeline. Importantly, the Microsoft.extensions.ai.evaluation libraries are built on top of the Microsoft.extensions.ai abstractions, which are the same APIs and building blocks that you'd be using when you're actually creating your AI apps. So this ensures that when you're passing outputs to your app into the eval libraries, it's going to be really straightforward, and the evaluators are compatible with just the broader .NET ecosystem that you're already relying on. So this is what the basic flow looks like for most of our evaluators. We have your AI app up here on the top left, which will receive a user query and then queries the LLM for a response. The request and the LLM response are then sent to meai.eval for evaluation. And then this eval response is going to be generated and saved in the report store. .NET AI eval is then going to process stored evaluations and can output an HTML report, which is what I will be showing you today. So now let's talk about what types of evals we have. It's worth pointing out that all of these evaluation libraries have been developed in collaboration with Microsoft and GitHub researchers, and they're tested on real GitHub Copilot experiences. These libraries do come with some built-in evaluators, and these are going to help you measure and improve your AI apps from within your development workflow. So I'm going to break down the types of evals that you can use. First, we have content safety. So this is all about responsible AI. These evaluators are powered by the Azure AI Foundry evaluation service, and they check for harmful or risky outputs. So that's things like protected material, unfairness, hate speech, violence, and even code vulnerabilities. Next, we have quality evaluators. And these measure things like relevance, completeness, coherence, and then even how well AI agents can actually handle tasks and use tools. And these evals do require an LLM connection because they're designed to ensure that your AI delivers responses that are basically aligned with user expectations. Finally, we also, for classic natural language processing tasks, have some evaluators for translation and text similarity. These are using metrics like BLEU, GLEU, and F1. And these won't rely on an LLM, which makes them pretty lightweight and just perfect for traditional NLP scenarios. The best part, in my opinion, is that while these libraries give you all of this out of the box, they're also fully extensible. So you can build your own domain-specific evaluators, you can define custom metrics, you can even plug in your own storage provider for eval results. And we have some really good examples of all of these on our .NET AI samples repo, so I definitely recommend checking that out so you can try some of these out for yourself. But enough with me talking at you. I want to see what this looks like in VS. So I have this test project here. It's basically a sample with tests for a simple AI assistant that's designed to answer specific questions about astronomy. So I'm going to walk you through what we have in this test project. First, I want to show you how we're setting up the reporting configuration. So here we're creating an iChat client to interact with a model deployed on Azure OpenAI. I've gone ahead and set up my environment variables to connect to my OpenAI endpoint so I can connect to my model and then selecting my model here. And then we have a system prompt here, which is basically just showing the AI system what it should be doing, saying you're an AI assistant that can answer questions related to astronomy, responses under 100 words, use imperial system measurements. So at the top here, we do have our tests. And this is where we're actually using the evals to test the response quality. We have one test where the question is, what is the distance between Earth and Venus? And one for the distance between Earth and Mars. And you can see in both of these, we have this like groundedness context here, which is just grounding the response in the context that we want for like this particular question. It's also worth pointing out that to use the MEAI eval libraries, we do have to have a certain set of NuGet packages installed. In this case, it's all of these things in these usings up here. And to install these, you can go ahead and search them on NuGet.org directly, or you can use the NuGet package manager UI in Visual Studio. So if I were to pull that up, you'd see that I have all of those already in my installed. So let's go to the Test Explorer and take a look at what we have there. I'm seeing my two tests here, and it looks like one of them is failing. So looking at that test output, it looks like there is an assertion that is failing for distance between Earth and Mars for groundedness. So let's look in our code what might be going on here. So for that test, I do have two assertions here, one for coherence and one for groundedness. Basically, just if that metric goes below a certain threshold, we want to fail the test. So let's generate an eval report so we can actually dig into this data and see exactly what's going on here. So I'm going to use the .NET AI eval reporting to do that. So I'm going to jump into my slides to show you how to install that tool. So first I need to install the tool locally under my project folder. So that will be this first command here. And then to generate the report and open it, I have this second command. That open flag at the end is going to automatically open the generated report in my browser. So I've already gone ahead and done that. So let's pull that up. Cool. So this is my AI evaluation report. We can see that the test for distance to Mars is failing. So let's click in on that one. And it looks like our suspicions are confirmed here. The groundedness score is not as high as we want it to be, and it's causing the test to fail. So if we click on each of these metrics, we can actually see like some of the details and the logic behind why we got the score that we did. So we can also see some metadata here, like if this is one of our built-in evals, which it is, it's our built-in quality eval, what eval model I used, and how many tokens were used for each metric of this eval. But let's check out groundedness and see what the issue was. So it looks like the evaluation reason is that the response provides partially correct information, but includes some inaccuracy regarding the closest distance. It introduces this term opposition, it looks like, which wasn't included in the grounding context. So it seems like this was like mostly correct, but the groundedness wasn't quite right, which is exactly what we were expecting to see here based on what we saw in the test explorer. Then if I scroll down, I can also see the actual conversation that the AI assistant had with our user, as well as the supplied grounding context. And if I scroll even further, I can see some diagnostic data here. So this is showing me for each of the chat responses, the total tokens, the model provider, the cache status. We can see that I had a cache hit for all four of these because I had run this before with the same prompt. So I was able to get my results super fast here. So overall, this AI evaluation report is really helpful just to get like a high level view of what's going on, but it also allows me to dig into the details. And this example is just for one of our evals, the quality eval. And we have tons more in the box, like I mentioned before, as well as the option to create your own domain specific evals and report on them in a way that works for you. Now, this kind of reporting isn't just like a technical exercise, it's about trust, right? In an increasingly AI heavy world, we can't afford to treat model outputs as a black box. So, evaluations give us this systematic way to actually measure quality and improve reliability before these systems are going to go and touch real users or business critical workflows. So, with that, let's jump back into the deck and wrap this up. So we covered a lot today. We had code coverage, live unit testing, code lens, using Copilot to understand failures, automated test generation with GitHub Copilot testing for .NET, and finally, how to use MEAI evals to evaluate your AI. And each of these features shares a common goal, which is making testing smarter and faster and just more reliable in an AI-driven world. Because AI isn't just changing how we are writing code, but it's also really changing how we want to validate it. And these tools that we talked about today can give us confidence that innovation is not going to come at the cost of quality. So that's all I have for you today. Thanks for joining me and tuning in to .NET Conf.